So today we're going to be looking at slopes of parallel and perpendicular lines. So a reminder, parallel lines are lines that never meet. Okay? And then perpendicular lines are lines that meet, but they meet at exactly a 90-degree angle. So the whole goal of today is going to be, what is the relationship between the slopes of parallel lines and what is the relationship between the slopes of perpendicular lines? So let's start off with parallel. So here I have two parallel lines and I'm saying, okay, well, what is the relationship between these? So let's look at what is the slope of the line A to B and what is the slope of the line C to D? So A to B, we rise 7 and we run 5. So this would be a slope of 7/5. For C to D, once again, we rise 7 and we run 5. So what we're going to figure out is that when we have parallel lines, the slopes are the same. So as soon as you find that one slope is exactly the same as the next slope, that means those two lines are parallel. They will never actually meet. So let's do a question here. We have the line GH that passes through these 2 points, and the line JK that passes through these two points, and MN which passes through these 2 points. Can we figure out if they're parallel or not? So I am going to start by drawing these points. So -4, 2 is our first dot, that's G. And then we have H is 2 and -1. So we'll make a line through that. I'll try to stick to the same colors. So the next one, let's do a red one. So this is JK this time. So we have -1 and 7. Perfect. And then we have 7 and 3. So this is K. So once again, I'll attach those two with a line segment. And then the last one we have M, which is -4 and 5. We have N, which is 5 and 1. And let's attach a line segment through those. Okay? So although we can look at them and see that two of these do look more parallel than the others, we do need to justify, which means we need to show mathematically that they are or they are not parallel. Okay? So that means I'm actually going to find the slope of the line GH. I'm going to find the slope of MN, and I'm going to find the slope of JK. And again, you're welcome to either read the graph here, or you can fill in that formula which we looked at last week, which was y2 minus y1 over x2 minus x1. Maybe we'll use the formula just to stay consistent. So for G and H, I'm going to subtract my y. So maybe I'll do this y minus this y. So -1 minus 2. And then I must keep the same order. So since I started with this one, I'm going to have to start with this x value. So 2 minus -4. So that's going to give me -3 over 6, which is just -1/2 when we reduce that fraction. So let's do the same thing with MN here. So, ooh, I'm on the wrong one. So let's do JK next. So JK. So again, I'll do y2 minus y1. So 3 minus 7. And then 7 minus -1. So that's going to give me -4 over 8, which is -1/2. So automatically in saying that this slope and this slope are exactly the same, so these two are parallel. Okay? Which makes sense. This line here looks as though it's parallel to this line here. This one in the middle looks a little sketchy, so it's probably not parallel, but let's validate that with some math. So let's do M and N. So I'll do this y minus this y, so y2 minus y1. And then we'll do x2, which is 5 minus x1. So we end up with negative 4 over 9, which is not negative 1/2. So this one is just another line. It is not parallel or perpendicular to any of the others. So let's move into perpendicular lines. So let's look at what happens to the line AB with its slope, and let's look at what happens to the line CD with its slope. Okay. So AB, here we're going up 3 and we're going, up 4, rising 4, and we're running 3. So it's going to be 4/3. Okay. But then for D, we're rising 3, but then we're running negative 4. So this time we have 3 divided by negative 4. So we need to figure out how these two are related. So we're looking at it being the negative reciprocal. So reciprocal means that you take this fraction and you flip it. So 4/3 becomes 3/4. And then it's the negative because if this one was positive, this one becomes negative. If this one had been negative, then the negative reciprocal would have actually ended up being a positive. So we're going to say it's perpendicular when we see the negative reciprocal. And again, just remember reciprocal means you're taking your fraction and you're flipping it. Let's try out a question. So we have the line PQ here, and then also the line RS. So we want to know, are they parallel, perpendicular, or are they neither? So are they just two lines with no relationship? So let's draw them out. P is -7 and 2, and Q is -2 and 10. So let's attach a line through those. And then we have R, which is -3, -4. And we have S, which is 5 and 1. So we have actually done B. We sketched them, but let's do A. So we're going to check to see. So again, we have to do this, the slopes of these. So let's find the slope of PQ. Let's find the slope of RS. Obviously, in looking at it, these are not perpendicular. So let's check. Let's just make sure. So the slope PQ, we're going to do y2 minus y1 and x2 minus x1. So we're going to end up with 8, and this is -2 plus 7, so over 5. So for RS, we'll do y2 minus y1, and we'll do x2 minus x1. So this is going to give us 1 minus -4, so that's 5, and this is going to give us 8. And although this looks as though it may be perpendicular when we're doing this, we do need to remember, yes, this is the reciprocal of one another, but it's not the negative reciprocal. There's not a negative sign here. So we cannot say it's parallel. These two are not the same. We cannot say it's perpendicular because it does not have the negative. So we have to say this is a neither case. So let's do this one. So determine the slope of a line that is perpendicular to this one. So let's draw it out. We have 2, 3, and again, I'm drawing it out each time. You do not need to do this. I think it's just nice to have a visual for some of you that may like to see what's happening. So this is E and F. So let's start by finding the slope of EF. This is always the greatest spot to start, is find the slope of it. So y2 minus y1 and x2 minus x1. So we'll get -4 over -6, which is going to negative divided by negative gives me a positive, so my answer will be a positive. And then 4/6 can be reduced to 2/3. Okay. So if I said I wanted a slope that is perpendicular, and this is the little symbol that we say perpendicular, kind of looks like a background, an upside down T. Again, that just means the two lines are crossing each other at a 90-degree angle. So that's just notation. You can write it like that. So a perpendicular line to this slope is going to have the slope that is the reciprocal. So it's going to have to be 3/2, but it's the negative reciprocal. So because this is positive to start with, the perpendicular line would be negative 3/2. So B is definitely the challenge one here. So determine the coordinates of G so that the line EG is perpendicular to the line EF. For instance, I want to create a line going through E that is perpendicular to the line EF. Okay, that's the goal. So in saying that, I want to find one other spot anywhere on this green line that exists there. And we're going to call that the point G. So let's start at the point E and let's draw this slope and see maybe what is the next point that it would hit. So if I start at E and say my y's are changing by 3 and my x's are changing by 2, or my rise and my run. Okay, so I'm going to rise -3. So I'm going to go down 1, 2, 3, and then I'm going to run 2, 1, 2. So the next point that could be on this line would be this point here, which is the point 4, 0. So you could absolutely give me that as a point if you wanted. You could keep going with this line, so keep going down 1, 2, 3, and running 2. So we could also get the point 1, 2, 3, 4, 5, 6, -3. Okay. You could actually do it in the opposite direction, just follow the same pattern. So we were going over 2 and up 3. Could have this point 0, 5. Okay? But as you can see, the possibilities are infinite here because this line could continue on in both directions. But again, all you need to do is continue the slope that you just found that was perpendicular, starting with the point E. One last question here. It's saying, okay, is this a rectangle? So a good reminder, a rectangle is square any of it. That means that these meet at 90-degree angles. Okay? So we're going to have to find the slope of AB, of BC, of CD, and then of AD. And make sure that these are perpendicular and that even AD is parallel to BC. Okay, so I'm going to do that up really quickly here because I'm almost running out of time in the video. So give me 1 second. So ta-da! Those are all the calculations. Now that we've been doing slope for a while, you should be able to find these 4 slopes of these 4 lines. But check it out. Make sure that when you did it, you were able to find these. So now let's analyze what we found. Okay, so AB here, the slope of it is -4/1, or just -4. And then BC is 1/4. Looking at it, these two here are perpendicular. First of all, look at this. This is the reciprocal and the sign change. So the negative reciprocal. Okay? Same thing happened here. BC is perpendicular to CD. Again, 1/4. The reciprocal is 4/1 and it's flipping the sign. Okay? And the same thing happens between CD and AD. And then AD and AB. Okay? And then the last thing we also noticed was that AD, we'll do this in a whole other color, AD is parallel to BC. And same thing with AB is parallel to CD. So in saying that, since all of these meet at perpendicular corners here, and the certain sides are parallel, we can say that this is a rectangle. Okay, try out the questions on the site. Email me if you have any questions whatsoever. Stay safe.